Hello students, welcome back to your online video classes. Today we will start our next chapter 10, that is electric current. Before starting electric current, we will discuss the heat current. Heat current is the flow of heat from high temperature to low temperature. So, this temperature difference generates a flow of heat and that flow is known as heat current. Like that, in electric current, there is potential difference which we will discuss later in detail, in which due to that potential difference there is flow of electrons and that flow of electron is known as electric current. So, the direction of motion of electric current is just opposite to the direction of flow of current. If electrons are moving from right to left, then current will move from left to right. So, you can say that direction of motion of electrons as well as current is opposite to each other. Current is basically charge divided by time, that is, in a circuit the amount of charge flowing in a given time period is known as electric current. So, the formula of current will be charge per unit time. So, now charge is the total electrons flowing at a particular time. So, you can say the charge of one electron is 1.6 into 10 to the power minus 19 coulomb. Coulomb is the unit of charge, and if there are n number of electrons flowing at a particular time, then this will be Ne divided by T. So, unit of current, that is coulomb per second, is also known as ampere. There are some smaller units of ampere. First of all, milliampere, in which there will be 10 to the power minus 3 ampere. Second, the more smaller one is 1 microampere. This is smaller than the milliampere and it is 10 to the power minus 6 ampere. So, this was about the charge, current and time, and you can relate that electric current is equal to charge per unit time and value of E, that is the value of charge of one electron is 1.6 into 10 to the power minus 19 coulomb. So, now definition of 1 ampere will be the flow of 1 coulomb charge in 1 second, that is 1 ampere. And I have told you the smaller units 1 milliampere and 1 microampere. So, one example is given in your book, example 1 on page number 132, that is find the number of electrons in 1 coulomb of charge. So, charge is given, total charge is 1 coulomb and total charge is equal to the charge, the value of charge of one charge and it multiplied by the n number of electrons. So, 1 coulomb is equal to n multiplied to 1.6 into 10 to the power minus 19, charge value of one charge, 1 electron. Then the number of electrons will be 1 divided by 1.6 into 10 to the power minus 19, that is 6.25 into 10 to the power 18. So, this was the formulas as well as units of electric current. Now, we will study the potential and potential difference. So, I have told you that current will flow from high potential to the low potential, like heat flows from high temperature to the low temperature. Potential difference is basically the work done for moving a unit positive charge from one point to another. That one point to another point is basically the potential difference. If it was taken at infinity, if one point is taken at infinity, then potential at infinity will be 0 and that point will be the potential of a charge. So, by the definition, you can say that the work done in moving a unit charge from one point to another is potential difference. So, VA minus VB, A is one point and B is the another point, is W by Q, that is work done per unit charge. So, potential difference is work done per unit charge. If VB, that is the point at V, is taken to infinity, then the value of V infinity is equal to 0. So, by definition, that is the formula VA minus VB is equal to W by Q. So, the unit of W, that is work done, is joule in SI, and of Q, that is charge, is coulomb. So, joule per coulomb is also known as volt, that is the unit of potential difference. Regarding the potential difference, an example, that is example 2 is given. The question is, how much work is required to be done to transfer a charge of 3 coulomb between 2 points with potential difference of 10 volt. So, in the question, potential difference is given, that is 10 volt, and charge is given, that is 3 coulomb. And as you know, the potential difference is equal to work done divided by Q. So, work done will be potential difference multiplied by the Q. So, work done is QV. So, by multiplying 3 to 10, then we get the work done, that is 30 joule. It means that moving a charge from one point to another, which are having a potential difference of 10 volt and the charge is having the value 3 coulomb, requires 30 joule of work to be done. So, the next heading is about the symbols which we will use in the electric circuits. So, in table 10.1, all the symbols of the components of circuits are given. So, let us start one by one. First of all, battery, that is also known as electric cell. The symbol is given in the next column and diagram of the equipment is given in the third one. Second one is key or switch, the switch which allows or stops the current flow, that is the switch, which is also known as key. Third one is variable resistance. Variable resistance have two more names, that is rheostat as well as current controller. So, by changing the value of resistance, you can change the value of current in the circuit. So, this resistance which we can vary according to ourselves, that is variable resistance or rheostat. Fourth one is voltmeter. Voltmeter is attached to measure the potential difference in a circuit. It is attached parallel to the circuit for measuring the difference. So, voltmeter is attached parallel to the circuit. Fifth one is ammeter. Ammeter is used for measuring the current, electric current. So, for measuring the accurate current, you will attach the ammeter in series to the circuit. Sixth one is electric bulb. For knowing whether the switch is on, off and knowing the intensity, we use the electric bulb. Now, the Ohm's law. This law was given by the German scientist Ohm in 1826, in which he, by using several experiments, told that the potential difference is directly proportional to the current flowing. So, the statement of Ohm's law is the potential difference between the terminals of a conductor is proportional to the current flowing through the conductor when physical states, that is temperature, pressure, length and area of cross section of the wire and length is also of wire. Then these potential difference across the terminals will be directly proportional to the current. So, when V is directly proportional to I, then by removing the proportional by equality sign, you will have here a constant. That constant is resistance. Resistance is the restriction of flowing of electrons. So, this restriction is basically resistance, which we will discuss later. Then the formula of R will be volt per current, that is the potential difference divided by the current flowing, and the unit will be volt per ampere, and this unit in the honor of the scientist Ohm is known as the unit Ohm and the symbol is given in the German. So, this was about the Ohm's law. There will be an experimental verification of Ohm's law in which the circuit used by the Ohms will be, in which every equipment except the potential difference measuring voltmeter are connected in series, that is the battery, switch, rheostat, ammeter and resistances of wire as well as any external resistance are connected in series, but potential difference measuring instrument, that is voltmeter, are connected in parallel. This experimental setup then tells that by increasing the potential difference, the flow of current increases. So, you can say that potential difference generated is directly proportional to the current flowing. to the graph which the ohm obtained is directly proportional, that is a straight line graph which is starting from the origin point. This was the graph which was experimentally verified by the Ohm scientist. Then an example which is given regarding the relation between R, V and I, that is resistance, potential difference and current, is given in your book on page number 134, example 3. That is, find the resistance of a conducting wire in which potential difference of 2 volts is produced when 0.5 ampere current flowing through it. So, in this question you have given the values of V, that is potential difference 2 volt and the value of current, that is 0.5 ampere. So, resistance will be V upon I. So, by putting the values of V and I particularly, you will get the value of R, that is 4 ohm or 4 volt per ampere. So, this was the example 3. After that, now we will discuss the resistance. So, you know that the wire of metal is made up of molecules. In molecules, there are several number of atoms. In atom, there will be a structure like, there will be a nucleus in the center and the external orbits will have electrons. So, molecules are composed of atoms, and in atoms there will be a nucleus surrounded by the several electrons. The electrons in the outermost orbit are not influenced very much by the nucleus. So, it is weakly attracted by the nucleus and are almost free for movement. So, by the thermal energy or by the external potential difference, this electron have the capacity to move. But there will be another atom near to the first one. So, it will be restricted by the nucleus of the other atom, and these kinds of restrictions in the movement of electron is actually the resistance. So, resistance is the restriction to the movement of charges, basically electrons, in conductors is resistance. So, by many kinds of experimental verifications and drawing the graphs related to the resistance, scientists knew several dependencies of resistance on various components. So, the first dependence is that resistance is directly proportional to the length of wire. It means that if a length is of 5 meter and suppose that its resistance is 5 ohm, then by increasing or by doubling the length of wire, that is 10 meter, then resistance will also double, that will be 10 ohm. You can say that resistance is directly proportional to length. If we increases the length of wire, then resistance of wire will increase. Second one is resistance is inversely proportional to the area of cross section. So, if you are increasing the area of cross section, then flow of charges will be less restricted and resistance value will be decreased. So, by removing the proportionality sign, you will get a constant which is known as resistivity. So, the formula of resistivity will be R multiplied to the area of cross section and divided by the length of wire. So, the unit of resistivity will be ohm meter square divided by the unit of length, that is meter. So, 1 meter will cancel from the upper one and then the unit of resistivity will be ohm meter. Resistivity does not depend on the dimensions of a wire, that is length and area of cross section, but resistance depends, as resistance is directly proportional to the length of wire and inversely proportional to the area of cross section. But resistivity depends only on temperature as well as on the material of wire. But resistance depends on length, area of cross section, temperature and the material of wire. So, first of all we have discussed the units of resistivity, resistance and dependence of resistance on length and area of cross section. Now, we will discuss the dependence of resistance on temperature. So, the resistance is directly proportional to temperature in case of conductors. In conductors, resistivity is low and the current flow is very large. So, resistance is also low, but by increasing the temperature, resistance increases. In semiconductors, by increasing the temperature, resistance decreases. That means in case of conductors, resistance is directly proportional to temperature in case of conductors, but in case of semiconductors like silicon and germanium, resistance is inversely proportional to the temperature. Semiconductors have an average conductivity and insulators have a very poor conductivity but very high resistivity. You can see the value of resistivity, which is also known as specific resistance, is very high in case of insulators. These values are given in table 10.2. Conductors have very low resistivity and alloys have an intermediate resistivity, which you can say can act as semiconductors like silicon and germanium. So, there is one more discussion about superconductors. Superconductors are having the value of R, that is resistance 0. So, this is a very ideal condition which never can exist in the nature, but the mercury at temperature 4.2 Kelvin, which is a very low temperature and cannot be attained so easily. So, at that temperature, that is 4.2 Kelvin, in mercury the resistance becomes 0 and the object having 0 resistance will known as the superconductors. Now, the next discussion about the dependence of resistance on material. So, some materials, you can say the conductors have very low resistance, and due to that the conductivity is very good. So, you can say that resistivity is inversely proportional to the conductivity, and some materials like insulators have very high resistance. So, they will restrict more the flow of charges, and due to the restricted flow of charges, current will also decrease. So, on page number 137, an order of resistance is given in your book, that is the resistance of aluminium is maximum among the aluminium, gold, copper and silver. And you know that the conductivity of silver is very good. So, resistance of aluminium is maximum, then gold, then copper, and the lowest resistance among these metals is of silver. So, the maximum conductivity among metals is of silver. You can see the sequence below the sequence of resistance, that is the sequence of conductivity for metals, that is silver, then copper, then gold and then aluminium. Our next discussion is about combination of resistances. So, first of all there is series combination in which a battery is connected and a switch is connected in series. There are several resistances which are connected in a single wire in a sequence R1, R2 and R3. They will have a different potential difference according to the values of resistances in the wire, but current will be always same in a series combination, that is in a single wire there will be always a single value of current. So, in first equation V1, that is the potential difference across the resistance 1 is IR1, V2 is IR2 and V3 is IR3. I is same in all the three ones, then the sum of all these potential differences V1, V2 and V3 must be equal to the external source of battery's voltage, that is V is equal to V1 plus V2 plus V3. Then by getting the value of V, that is equal to I multiplied to the R equivalent, then adding these values you get the value of R equivalent, that is R1 plus R2 and plus R3. So, related to this combination of resistance, an example 4 is given in your book. The question is, resistances of 3 ohm, 4 ohm and 5 ohm are connected in series in a circuit in which a battery of 6 volt is also connected. Then you have to calculate the value of current in each resistance and potential difference across each of the resistance. So, the question in which there is a battery of 6 volt and resistances are given whose values are 3 ohm, 4 ohm and 5 ohm. Resistances are 3 ohm, 4 ohm and 5 ohm. So, R equivalent, as these are in the series, then we will add up these all. 9 plus 3 is 12 ohm and current is V by R, that is 6 by 12, it means 0.5 ampere. As current will be same in all resistances, so current will be 0.5 ampere in all one. So then V1 will be 0.5, that is current which is flowing in the series, and R1, that is 3 ohm. The value will be 1.5 volt. So the potential difference across the 3 ohm is 1.5 volt. V2 is 0.5 multiplied to the 4, that is 2 volt, and V3 is 0.5 multiplied to the value 5, it is 2.5 volt. You can see that by increasing the value of the resistances, the numerical values of resistances are increasing from 3 to 4 and then 5, but the value of current is same, then potential differences are also increases with the value of resistance. So today we have discussed the basic definitions of current, potential difference, then we studied the Ohm's law and get the value of resistance, then we studied what resistance is, and now we are discussing the combination of resistance. We have discussed the series combination and we will discuss the parallel combination in the next class. Thank you.